Everyone, I'm Wendy. I'd like to talk about ANOVA table today. ANOVA table is pretty famous when you use computer for analysis. You will see ANOVA table here and there. Let's see how to make ANOVA table. Alright, ANOVA table organizes sum of squares, SS, and degrees of freedom, basically. Okay, we have seen earlier is called analysis of variance table. Sources, sum of squares, degrees of freedom, and mean squares, f value, and this one is p value. Okay, so this format is standard format. I think some statistics software provides a little different ANOVA table, but it is a standard format. Sum of squares here, total sum of squares, treatment sum of squares, residual sum of squares, say SST, SS treatment, SS error, or residual. Each of them has degrees of freedom. So source is A. This is like some factor, okay? Only one factor here because one way ANOVA table. SST, total sum of square here, okay? SST treatment sum of square, this value will be printed out here. And residual sum of square, error sum of square, SSE, the calculated value will be show up here. Degrees of freedom, K-1, here, residual, SSE, K groups times each degrees of freedom, each of group, okay? So N-1 times K. Mean squares is SS divided by its degrees of freedom. SSE divided by K times N-1, MSE. This is also very useful or famous terminology, MSE. F value is SST, the value of SST divided by value of MSE. Okay? That F value up here and the P value. The treatment sum of squares divided by its degrees of freedom, this one, and residual sum of squares divided by its degrees of freedom are called mean square for treatment. Mean square for treatment. This one is mean squares for error, MSE, respectively. The tested statistic, F, is the ratio of MST to MSE, like this. This is a tested statistic, MST divided by MSE. The value of F follows F distribution with the degrees of freedom, numerator, degrees of freedom, K-1, denominator, degrees of freedom, K times N-1, 2 degrees of freedom, okay? In the principle of analysis of variance, previously in this lecture, the ratio of between group variance to within group variance, we use this kind of ratio for tested statistic. It's referred to as F value. I told you. Let's see what is matching with these ones. Let's see the compare those variances with ANOVA table. Between group variance like this is just MST, right? N times between group variance, okay? Kind of this divided by N, then this one, MST. Within group variance, estimate of course, is like this, okay? This one divided by its degrees of freedom, MSE, okay? Here. Otherwise, you may come back to earlier this chapter, principles of analysis of variance. Okay, so exactly equivalent between group variance estimate within group variance estimate are MST and MSE. So I tried to explain the principle of analysis of variance. The principle is we have to use between group variance and within group variance like this. But in this one-way ANOVA model, we obtain as MST and MSE. MST means between group variance, MSE means within group variance. You know what I mean? Okay. And here, can you distinguish between lowercase letter, this one is a lowercase letter, and uppercase letters? These are uppercase letter, okay? Uppercase means random variables. This one is called estimator of within group variance. Small letter, estimate, some value of estimator. I like to distinguish these two lowercase and uppercase letter because statistics can be understood easily. Otherwise, you know, in some you get in a wrong way. Okay, let's see a simple example. To test whether there are differences in student performance based on teaching method A to A, B, C, D, E. And 6 students each were selected for each method. 6 of them here. 6 of them for B, something like that. The issue here is to test the hypothesis that all treatment effect for method A, B, E are equal and 0, like this. Treatment effect A, treatment effect B, treatment effect E are equal 0, okay? Based on the factor of teaching method. What is a factor? Teaching method. Where is it? Teaching method. Any difference among 5 teaching methods? So one-way ANOVA model and null hypothesis are like this. You know that, this one. And when you use computer provides this kind of ANOVA table. Here is degrees of freedom first appeared. Sum of squares, mean squares, F value, P value, right? So sum of squares is 85356. Degrees of freedom, 4. We are trying to compare 5 groups. So 5 minus 1, 4. And residual error, 124020. Okay? And degrees of freedom, here, from here to here, they are 6 deviations, squared terms. So what? Degrees of freedom is 6 minus 1, 5. Here, 6 minus 1 and 6 minus 1. So 5 times 5, 25 degrees of freedom. That calculated value of sum of square error, SSE, is this value, 124,020. And each sum of square divided by its degrees of freedom is mean squares. 85356 divided by 4 is 21,339. And this value, 124,020 divided by 25 is 4,960. Okay? What is this? MSE. Okay? MSE is real estimate of variance. 5 populations, their variances are equal. Okay? what is the estimate of sigma square? That value 4960 MSE is the estimate of this value. This one is from what? Within group variance, right? So, and F 4.30 is what? 21,339 divided by 4960. That is 4.30. That is value of tested statistic F. And this one is p value 0.08752. What is that? There is F distribution with degrees of freedom, what? 4 and 25, right? Your F value here is 4.30. That p value here, this one is p value, so this area is 0.008752. Okay, get it? So you have to understand the ingredient, I mean, that how to elements of this ANOVA table. Let's see F table. Here, F table is for many degrees of freedom. DF1 is numerator, degrees of freedom, upstairs. DF2 is degrees of freedom, downstairs, denominator. Okay, so this one 4, we are looking 4 and 25. F 4 and 25. The tail area is 0.05, alpha equal to 0.05. The value is what? 2.76. We got 4.3 for that previous example, simple example. So tail area is 0.0052, something like that. This kind of F table is, I mean, the statistics textbook has many this kind of table, F table. You can find it, F table. But when we use computer provides us the p value, so we don't have to look up that kind of a F table from now. Okay, all right. This is introduction of ANOVA table of one-way ANOVA. We will study two-way ANOVA. Two-way ANOVA will be a little complicated, so you have to know the ANOVA table for one-way ANOVA model. All right? Thank you. Bye now.